Okay, you guys ready? So last class we were talking about global warming mostly from a political standpoint, and we ended here, and we actually went through most of these terms, but it's probably good to review it today given that everything we're going to talk about sort of stems from these terms. So we were talking about climate change last class, and there's a lot of terms that kind of get kicked around in the popular media when it comes to discussing climate change. And the problem is that these terms are not all the same, and they lead to some confusion among people. Global warming, greenhouse effect, climate change, these are probably the three terms that you hear the most associated with this topic, but they're not the same thing. So global warming simply means that average temperatures of the atmosphere increase. And that could be due to a lot of things, though. Anthropogenic global warming, as we talked about last class, is that humans are making the average global atmospheric temperature warmer. The greenhouse effect is where the atmosphere is warming because we're increasing the amount of heat-retaining gases. Now that could be anthropogenic. Humans could be doing that by burning fossil fuels. It's also possible that these things can happen without human interaction. So the greenhouse effect doesn't imply that humans are responsible for changes in the average temperature of the atmosphere. It's a possibility. It just says that that's the reason why the atmosphere is warming. Climate change is kind of the preferred term today because it encompasses more than just the atmosphere warming a couple of degrees. If that's all that happened, just the atmosphere warmed up a couple of degrees, we probably wouldn't be as concerned about it. But that small change in atmospheric temperature can lead to lots of different things that can affect humans, can affect ecosystems, can affect animals, can affect plants. So climate change is more than just warming of the atmosphere. It includes changes that happen to ocean currents, changes that happen to growing seasons, changes that happen to weather patterns. We know that as temperatures warm, we get more evaporation, which makes drought conditions worse. We also know that as temperatures warm, a warm atmosphere can hold more moisture than a cold atmosphere, so that when it does rain, you tend to get more moisture during the rainy times. So it can lead to bigger floods and greater droughts at the same time. And I think we ended somewhere around here where we're saying that the global climate change events have occurred many, many times in Earth history. Some of these may have had changes in greenhouse gas compositions, some have not. But the climate is always changing. And then we sort of ended around here last class when we started talking about some other terms, climate and weather. So this is something that a lot of people confuse when they talk about global climate change. You hear this all the time. It's like, oh, we've had such a cold winter here in Colorado. That must mean that this climate change stuff we're hearing is all a hoax. That's weather, people. You know, we had a couple months of weather that was colder than average, but other parts of the world were probably much warmer than it had been in the past. Weather is the atmospheric conditions at a certain time and place. Like if you went outside today, it's 40 degrees and cloudy and humid for Colorado. But the weather a couple months from now might be a lot colder, might be a lot warmer. It's just what is going on with the atmosphere at a certain time and a certain place. Climate is what we're really concerned about, and that's the average atmospheric conditions over an extended time period. Here in Colorado, if you look year after year after year, we're a fairly dry climate. We get 10 to 20 inches of rainfall a year. It's a very sunny climate. We get 300 plus days of sunshine a year. We have temperatures that can get into the hundreds, and we have temperatures that can get well below zero. That's much different than what you would get if you lived in Florida, where it's very humid, it's cloudier, the temperature range is much narrower, it rarely freezes. So I use this in last class as kind of an analogy for climate and weather. Weather is the clothes you have on. I'm looking at all of you right now. You're all dressed to be warm. Jesse has on the big furry coat. Now, if that was the middle of the summer, I doubt you'd be wearing that unless you're going into an air-conditioned building. Climate, though, that's the clothes in your closet. The clothes in your closet, if you live in Colorado, is going to be much different than the clothes if you lived in Florida, even though the weather on any given day could be similar. We can have very warm days. We can actually have warm, humid days here in August when we get monsoons that come up from the south. But the clothes in your closet living in Colorado is going to be much different than if you lived in Alaska, and much different than if you lived in the tropics. But on any given day, it could be warm, sunny, and dry, just like it is here in Colorado. Okay, so some other terms. We're talking about some of the major gases that play a role in the climate change discussion. CO2 is the one you hear about the most, carbon dioxide. When we talked about energy a few weeks ago, one of the types of energy was chemical energy, burning things. And typically what we burn here on planet Earth is carbon-based. We burn wood, carbon-based. We burn fossil fuels, carbon-based. A lot of parts of the world, they burn animal dung, carbon-based. And whenever you burn something carbon-based, the byproduct is CO2, carbon dioxide. So just about everything we burn gives off carbon dioxide. There are some natural sources of carbon dioxide as well. It's a major volcanic gas. Remember, most of the gases that come out of a volcano are actually water vapor, but several percent of volcanic gas emissions are CO2. The thing about carbon dioxide coming from volcanoes is that as we look back over the last few thousand years, there doesn't seem to be any increase going on. We definitely have an increase of carbon dioxide going on in the atmosphere. I'm going to show you some charts here in a minute. But that can't be attributed to volcanic gas emissions because they've stayed relatively constant for thousands of years. The important thing about carbon dioxide is it's a heat-retaining gas. We sometimes call this a greenhouse gas. If you put more of these gases into the atmosphere, they simply hold more heat. And that's going to result in the average temperature of your atmosphere warming up over time. Now that we have almost 8 billion people, and most of these 8 billion people are either burning things for energy, directly or indirectly, that means we're putting a lot of carbon dioxide in the atmosphere. And in fact, just during my lifetime, carbon dioxide levels in the atmosphere have essentially doubled. Methane is the other gas that you hear a lot about. It's also a carbon-based gas, but it generally is produced by decaying organic matter. And a lot of it is stored in the ground, where lots of our plant material decays over time. It's actually a much better heat-retaining gas than carbon dioxide. And some scientists suggest that we should be talking more about this gas. One thing it has in our favor is that it doesn't stay in the atmosphere as long as CO2. CO2, once we make it, it stays in the atmosphere a long time. Methane, not so much. But there's lots of methane in the world. Sadly, there's lots of methane in polar regions, in permafrost. And one of the things very concerned about with the whole climate change discussion are feedbacks. Feedbacks are changes that cause other things to change as well. And what's happening in the Arctic is temperatures are warming up. As temperature warms up, more permafrost melts and more methane gets out of the ground, which warms the atmosphere, which melts more permafrost, which allows even more methane to get in the atmosphere, which allows the temperatures to get higher. So it's this feedback where warmer temperatures lead to more methane, which lead to higher temperatures, which lead to even more methane. And the concern is that we're going to start one of these feedback cycles that we can't stop. Fossil fuels, we talked about this extensively over the last couple months during our energy chapter. This is coal, oil, natural gas. When it comes to thinking about it from a climate change perspective, remember all of these were, all this stuff was life at one part, carbon-based life. And what this carbon-based life did was it took carbon out of the atmosphere. Think about plants. What do plants do? They photosynthesize, which means they suck in CO2, and then through photosynthesis, they produce energy, build their cells, and they give off oxygen. And then when they die, that carbon that they extracted out of the air goes into the ground, and in the case of fossil fuels, turns into coal, oil, and natural gas. So what's happened over millions and millions of years is that carbon dioxide has been extracted from the atmosphere by plants and stuck into the ground as fossil fuels. Fossil fuels are essentially a store of carbon that used to be in the atmosphere. Plants took it out, and then plants became fossil fuels. So that carbon went from the atmosphere to the plants to fossil fuels. And it took millions of years for that to occur. And then what have we been doing in the last 40 years? We've been burning fossil fuels at a ridiculous rate. All that carbon that it took natural processes to extract out of the atmosphere over millions of years, we turn around and we poof it back into the atmosphere within a couple of decades. And obviously, that is going to greatly affect our climate. Okay. There really is no debate when it comes to climate change. Scientists know that the climate is changing. The climate has always changed. If somebody says to you, I don't believe in climate change, they're just wrong. There's no argument to have with them. They're wrong. The climate has always changed. That's not what we're talking about here. What we're really concerned about is, are humans changing the climate at a rate that's going to adversely affect us, ecosystems, plants, and animals? So the first thing, one thing scientists agree on, the climate is changing. But it's always changed. If you look back through geologic history, it's changed a lot. When the dinosaurs roamed the earth, it was way warmer. The average temperature on Earth when the dinosaurs were around was about 90 degrees. That's the average. Even at the polar, when you average everything together. Much, much warmer than today. So it's changed a lot. And just over the past 100,000 years ago, we've had a bunch of ice ages. Now, it's unlikely humans were responsible for any of those. We had ice ages, and then we had periods between the ice age where the temperature would get warm. And then they get cold, and we'll go into another ice age. Get warm between them, get cold again. We just had an ice age 10,000 years ago. 10,000 years ago, we had animals like saber-toothed tigers, mastodons, woolly mammoths. That was very short geologically. But the climate changed. What happened to all those animals? They went extinct. What if we changed the climate enough? That means the animals that are here today could go extinct. Guess what? We're animals. Going extinct is not good if you're an animal. You don't want that. What we are really concerned about is everything we know about climate change is that we right now are changing the climate faster than at any point since humans have been here. When things change quickly, they're hard to respond to. We're used to the world being a certain way. We've built our world according to the climate that's been here. In other words, we have cities on coastal regions. Remember where do most people on the planet live? They live on coastlines. Well, if we change the climate fast enough, there's going to be a series of events that take place that include melting the ice at the poles, and it's going to change the position of the shoreline. Which means that a lot of areas that are currently inhabited by humans are going to be underwater someday, and probably very soon. That's going to result in an awful lot of upheaval and difficulty. The other thing, CO2 and methane are both at their highest levels in human history. It's just a fact. There's no arguing this. Humans have been around for about 2 million years. We have a record of atmosphere from ice cores. If you remember the video you watched last week, ice cores trap little bits of ancient atmosphere. So we know what the gases were like going pretty far back in time, all throughout human history. And right now, CO2 and methane are at their highest levels. And if you look at what's happened between atmospheric temperature and these gases, since humans have been around, temperature and these gases track very well together. When levels are high, temperatures are warm. When CO2 and methane levels are low, temperatures are cold. Right now they're the highest in human history. That suggests that our temperatures are going to be the highest in human history as well. Okay, what I have here is a plot of CO2 in black versus average global temperature in blue, going way back in time. We're going back almost 600 million years, okay? Humans have only been around the last 2 million years, right there. So we're basically on this line. And in fact, with the time span of this graph, you can't really see what's happened during human history. So assume right now, this sort of predates human history. And if you look, you can see that back in the Cambrian period, over 500 million years ago, look at CO2 levels. Really high, right? And you can see them gradually dropping all the way throughout the Paleozoic, right? Sometimes they go up a little, but mostly they go down. And what's interesting is what's happening during this time period. When you go to the beginning of the Cambrian, there were no land plants on Earth at that time. That's when life first got started in the oceans. But there really wasn't anything going on the land. If you were out on the land, you might see a little green slime, but that's about it. You're not going to see grass. You're not going to see trees. The world was not like it was today. Lots of rock. That's what the continents were. But then, especially during the Devonian and the Carboniferous period, the Carboniferous period is when land plants really got going on the continents. And look what's happening as land plants get more abundant. What's happening to CO2 levels? They're dropping, right? So the black is the CO2, okay? So CO2 was really high, and throughout this time period, when plants are developing, it gets lower and lower. What's happening are plants are becoming more abundant, and they're sucking CO2 out of the atmosphere, and atmospheric CO2 levels are going down. But is temperature following CO2 very closely during this time period? Not really, right? CO2 is dropping, and yeah, look at temperatures. It's stable, it takes a big drop, goes back up, takes a big drop. They're not coupled well together. This time period right here, the Mesozoic, that's the age of the dinosaurs. You can see that temperatures were high. What's going on with the black line, CO2? It's kind of bouncing around, isn't it? They're not coupled. There's other things going on there. So CO2 is not really controlling temperature. And if you hear people who deny that the climate is changing or the climate is changing from human interaction, they'll say, oh, CO2 and temperatures, they don't always follow one another. That's absolutely true, right? But guess what? Humans weren't around during any of this time period, okay? This was the age of the dinosaurs right here. This was the age of ocean critters. This was when plants first started coming up. Humans aren't even a twinkle in anything's eye at this point. But let's look at since humans came aboard, so basically right where this black line is on the end. Okay, so the black line right here starts there and goes way up right here. Those are methane levels, okay? This thicker sort of gray line right here, these are CO2 levels. And then the red line is temperature. So you've got methane, CO2, and temperature all on the same graph. Okay, take a look at what happens about 350 million years ago. What's going on with CO2 and methane? It's been sort of dropping, right? What's happening with temperatures during that time period? They're dropping, right? And look at right here, about, I guess this is about 325,000 years ago. What happens to CO2 and methane? They shoot up, right? What happens to temperature? It shoots up. And then guess what? It goes down, and it goes up, and it goes down, and it goes up, and then it goes down. And temperature kind of tracks with it, right? Temperature goes up, temperature goes down. Well, what I really want you to pay attention to is, let me see if I can do this. Get rid of my scribbles here. So this is today. There is CO2 level. CO2 has now hit well over 450. So CO2 is up in here. Highest point in human history. And temperatures are following very closely, right? Look at methane. There's the methane level. So anybody who's reading this graph, okay, you're watching CO2 and methane go down, what happens to temperature? It drops, and we get an ice age. And then they go up, and we come out of an ice age. And then they go down, and we're back in an ice age. And they go up, and we're out of an ice age. And they go back down, and we're in an ice age, out of an ice age, in an ice age. They're going up, right? We've come out of an ice age, right? True. They warm up naturally, right? Do you think this is natural? See how fast that is? And CO2 is following too. So it's pretty easy to understand why scientists are concerned about this. Because if temperatures are following and temperatures end up somewhere in here, this is not going to be a world like what we have today. Will we survive it? I don't know. But places that are already warm, places that are unbearably hot to live without air conditioning, now 10, 15, 20 degrees warmer. Can you imagine a place like Phoenix routinely being 150 degrees? Are people going to live there? Not if they have to, right? Not if they don't have to. They're going to move. So you're going to see massive migration to other places. And that's the concern, because whenever you have massive human migration, you get conflicts. You think Canada wants to see 300 million Americans crossing the border to move up there? No. So that's the difficulties we're talking about. And then sea levels are likely to rise too as ice caps melt. All those people have to go somewhere. If they can't live where they are now, they have to move. That's a massive economic loss. That's a massive uncertainty. It's massive instability. That's where the concern is. So, one other thing that scientists agree on, and that last chart shows it very well, is that humans are playing a significant role. It's probably not all us, okay? Because remember, we just came out of an ice age. So we should be warming up, we should have higher CO2 and methane levels, but not this high. You can just look at that chart and see that hasn't happened any time in human history. And there's no other way to explain it. Volcanoes aren't suddenly erupting at a greater rate. There's nothing else we've been able to identify as a natural process that would change the gases that fast. And that's where a lot of study is today. It's just how much of this is us, and what is it that we're doing exactly? Fossil fuels take a big rap, but it's not the only thing going on here. Some of it is food production. We are going to places like the Amazon basin. We're mowing down the rainforest, which used to suck in lots of CO2 and give off lots of oxygen. We're taking out the trees to make grassland for cows so that we have beef. But as you take away the plant cover, you take away the Earth's ability to take CO2 out of the atmosphere at a time when we're putting record amount of CO2 into the atmosphere. We need these rainforests to remove some of the CO2 that we're pumping into the atmosphere through fossil fuel burning. But the best estimates right now is maybe 30% of our warming is natural, coming out of an ice age, but the rest of it's us. So we're changing it at a faster rate. It's not that this is unprecedented in terms of the Earth warming up. The Earth's actually been a lot warmer than this in the past. Go back to when the dinosaurs roamed the Earth. Way hotter than it is now. But we didn't live there, and we probably wouldn't survive very well. It was really great if you're a reptile, if you're cold-blooded. You like that kind of world. Mammals, we're cold-blooded. We have to regulate our body temperature, and if the air temperature is hotter than our body temperature, that means we're constantly trying to cool off. And that's really difficult. And then to bring politics back into this, of all the developed countries in the world, sadly, the U.S. has the lowest belief in a scientific fact. That the climate's changing, it's changing faster than ever, and we're partially responsible for it. It is changing a little. It is increasing. 15 years ago, it was about 50% of the U.S. population said, yeah, this is important. Humans are changing the climate. Now it's up in the 60s. That means 30-some% just do not want to believe this. And that's still far too high a rate. And it's too high a rate because we can't get anything done as a country if that's the case. You've seen the political divide on this issue. It's really difficult to get leaders to do anything when a third of the population is dead set against it. This is kind of interesting. This is from January 2015. Okay, this was when Obama still in office. Somehow the Democrats in the Senate managed to force the Republicans to vote on 3 things that they didn't want to vote on. But through procedures, they were able to do this. And the first thing was, they asked senators, is climate change real or a hoax? And as it turns out, 98 out of the 100 senators said, yeah, climate change is real. That's good. It'd be better if it was 100%, The funny thing was, Senator from Oklahoma, James Inhofe, voted yes, climate change is real, a couple months after he published a book that said climate change was a hoax. So a lot of politics that get played with this thing. They ask him another question. Is climate change real, and are humans contributing to it? And now it looks more like the general public, okay? A lot of people are saying, yes, climate change is real, but no, humans are not contributing to it. A lot of folks believe that the Earth and the atmosphere is simply too big for humans to mess it up. And I think I know why Americans have a hard time with that, and I'll show you why in a minute. But as it turns out, about 60%, which is kind of where we are today, said, yeah, hey, climate change is real, and yep, we're doing something about it. And that even included 15 Republicans. And then finally, they were asked, is climate change real, and are humans significantly contributing to it? And then you get pretty much party line. 5 Republicans voted for this, but most of them didn't. Because if you say significantly, and you agree that it's significant, then you're kind of on the spot to do something about it. And if you say it's not significant, then you can just keep going on your merry way and not do anything. So this is pretty important change in wording right here. But you can see that even the Senate knows that climate is changing. And like I said, you have to believe climate is changing because it's always changed. The real concern is, are humans contributing to it? And we are. And is it significant? Sadly, it is. And it's taking our elected officials and the general public a little while to catch up. Now, I don't believe that's because people are dumb. We went back, remember last class, we were talking about who the deniers are. They're smart people. They're successful people. They're generally good people. They just don't believe humans are doing this. And I think there's a really good reason for them not to believe it. And that's that you can't see it. It's hard to believe in things you can't see. What's interesting is, of all the developed countries in the world, China has the highest belief in climate change. And I'll show you why I think that's a big deal here in a second. Okay, we'll come back to those things in a few minutes, but a few more things that scientists agree on. Remember, we're talking about what scientists agree on. We don't agree on everything with respect to climate change, but we agree on a lot. We agree on some fundamental facts. And in fact, this whole climate change body of work is nothing new. Actually, the first scientific paper to discuss a link between climate change and humans was back in the 1800s. Physicist was looking at CO2 levels and said, hey, we're in the industrial age. We're burning things. We're putting more CO2 in the atmosphere. Even back then, they knew that this was likely to change the climate. And the first person to suggest that humans could change the climate was Arrhenius, and that was back in 1896. And he was proven true about 50 years later. Interestingly, the US Air Force was the one that proved him correct. If you remember back to the video you watched, they were just trying to figure out how to make better heat-seeking missiles. And to do that, you have to understand how the atmosphere deals with heat. So they started looking at CO2 and started measuring CO2. Because warming temperature messes up your missile's ability to find its target. And in fact, the US Air Force, back right after World War II, found out that, hey, the atmosphere is warming, and it's messing up our ability to hit our targets with our heat-seeking missiles. And that CO2 was likely the cause of the warming. Like I said, in my lifetime, CO2 levels have almost doubled. They were as low as 250 parts per million. Now I'm going to need to change this because it's going up so fast. It's up around 450 parts per million. And like we saw in the chart a few minutes ago, humans have never lived with CO2 levels this high. And remember, temperatures follow CO2. So the temperatures are soon probably going to be at levels that humans have never dealt with. Now, luckily, we've advanced a lot as a species, and we have lots of technology that can help us deal with these increased temperatures. But it means we're entering a world that humans haven't really lived in before. And a lot of the plants and animals that we have out in the world, they've been used to colder temperatures since the last ice age. And now we're going to put them in a nice hot room for the rest of for the foreseeable future. So between 2000 and 2016, and I'll update this soon because obviously the trend has continued, 15 of the 16 hottest years ever recorded were those 16 years from 2000 to 2016. And the hottest on record in 2016. And that's continued up to last year. It's now, I think, 18 out of 19 of the hottest years ever have been since 2000. But if you happen to live in one part of the world, sometimes you have cold weather for a year. I remember back, I think it was 2009, 2010. I moved here in 2007. And it wasn't not long after that we just had a brutally cold year here. In fact, you couldn't drive all the way up Pooter Canyon. They had it closed off halfway up the canyon because there was so much snow and the avalanche danger was so high. They had that road shut for months. This year, there's hardly any snow at all up there. But just because you get one cold year here doesn't mean that climate change is a hoax. Because if you look worldwide, you'll see that most of the Earth is really much hotter at the same time. I think I have some examples here. Okay, here's temperatures from average for January of 2015 compared to the average from 1951 to 1980. Okay, so take all the temperatures in the region from 1951 to 1980, it's a certain temperature. And then how does that compare to the temperatures in 2015? Was everywhere hotter? So yellows and reds are hotter, blues are colder. There's some blue, right? Yeah, look at this area right up here. Northeast part of the US, Nova Scotia, parts of Canada. They were colder than the average. They were colder than the average from the 1950s to the 1980s. And down here in the Antarctic, it was colder. Sub-Saharan Africa was colder. This little bit out here off of Japan, a little colder. Little colder. But look at the rest of the world. Much, much hotter. Asia, ridiculously hot. Most of North America, ridiculously hot. Look at the Arctic. Arctic was just baking. And then pretty much everywhere else, it was warmer. If you average it up, it's warmer. Yeah, there's a few areas that were colder during the month of January compared to the average. Most of the world was hotter. And when you add it all up, the world was hotter. And that's the problem, is that something can be happening to you that's much different than the bigger picture. So, yeah, you could be on the butt end of the Titanic right there and be up in the sky, but eventually you're going to be at the bottom of the ocean. It's not going to work out for you. So, you know, we've had U.S. congressmen and women bring snowballs into Congress and say, look, no global warming. Just because it's cold in D.C. doesn't mean the rest of the world's not warmer. Drives me nuts. Okay, there are some things that scientists do not agree on. But just because we don't agree on every detail of how the process is working doesn't mean that we don't understand the big picture at this point. We understand the big picture. Climate is changing. Humans are partially responsible for it. Probably mostly responsible for it. What we don't agree on really is the future. We know that it's going to keep warming, but we don't know how fast. So we're putting together these very big, elaborate computer models to try to give us some idea of what might transpire in the future. But computer models are not perfect. They're not reality. But we get better with them as time goes on. As time goes on, computer models track what's really happening in nature better and better and better. And what's happening with computer models is they're showing that it's going to warm and it's going to be fast. And there's not much doubt about that anymore. But we can argue whether it's 1 degree centigrade in the next 15 years or 1.3 degrees centigrade in the next 15 years. But it is going to rise and it's going to be significant. This is the big one, is just because temperature gets warm, what does that mean? What's going to happen? What's going to happen to the oceans? What's going to happen to the melting of the ice caps? What's going to happen to growing seasons? What's going to happen to insect hatches? What's interesting is you can get large hatches of insects. And what's happened over the last 10,000 years is things that eat those insects sort of match their season. You know, so if you have mosquitoes, bats like to come in at the time when the mosquitoes are hatching. But what's happening now with climate change is insects are hatching way earlier. And sometimes their predators are slow to follow. So you end up with way more bugs in some areas than you might get. And we're seeing higher and higher incidences of things like malaria already. We have malaria creeping in the United States. Some of the southern states are now worried about malaria rates going up. That's not something we've had to worry about here in the U.S. It can change the growing seasons. The atmosphere is a complex place. It has lots of different gases. We focus a lot on CO2, but there are other gases as well. Methane's important. The sulfur gases are important. Some gases block out a lot of the sun's energy. And then other gases like CO2 and methane hold on to it. So we need to know what some of these other gases are doing as well and how they're going to affect the climate over time. And again, that comes down to computer models. And this is the big one. We could have 50 people in this room who know the climate is changing, understand that humans are significantly affecting it, and end up with 55 different ideas on what we should do about it. Scientists definitely don't agree on what we should do about this problem, both personally, politically. Some scientists want the government to intervene. Other scientists don't want the government to intervene. Some scientists believe we should be going into engineering approaches right away to suck CO2 and methane out of the atmosphere. Others think that that could be a really dumb idea. So we definitely don't agree on what we should do about it. And that makes moving forward difficult. All right, I told you a minute ago that different cultures and countries view the climate change situation very differently. So this was a poll of 20,000 people, occurred back in 2014. It was a UK-based study, but they polled 20,000 people in 16 different countries about various topics related to climate change. And one of the questions they asked was, to what extent do you agree or disagree with the following statement? The climate change we are currently seeing is largely the result of human activity. And if you look at China, nearly 90% of the people they polled there said, yep, climate's changing, people are doing it. And look at what's on the bottom of the list. There's the good old US of A right down there on the bottom. Just slightly over 50%. Very different, right? How can you end up with such varying opinions among developed countries around the world? And especially the US and China, which are the two biggest emitters of CO2. US is the biggest, China is the second biggest. And yet China knows that all of their emissions are screwing up the climate. In the US, we just want to sit and argue about it, right? Why? And yet here in the US, we have very educated people. You would think that they should know this stuff, right? And clearly they don't. Here's another way of looking at it. To what extent do you agree or disagree? We are headed for an environmental disaster unless we do something about it. There we go. China right on top. We're headed for a disaster. US, half of us think so. A few percent don't know. And about 30% say absolutely not. Again, that's a sizable portion of the population. Makes it real difficult for political leaders to act on this. Very different, right? I think there's a reason. This isn't proven, but I think this is a reason. This is Beijing. This is what Beijing normally looks like. That's a normal day in Beijing. It's one of the most smog-laden, dirty air environments you will ever see in your life. This is a rare day where it's really windy. You can actually see what's going on. I had a friend who worked in one of these buildings, and he said some days you could not see across the street to the other building. It was that ridiculous. What's our air like here in the US? Even we get air quality alerts here in the Front Range, and you still see the mountains, right? Have you ever seen air that looks like this? No. I have seen air. I grew up in the 70s, and in the 70s was kind of the big age of environmental legislation in the US. We passed the Clean Air Act. We passed some Clean Water Acts. The air in places like Cleveland, Ohio, LA, used to be really terrible. It wasn't this bad, but it was bad. You could see the air. You could taste the air. You could smell the diesel fuel. It was making people sick. And we put in new air quality standards, made industries change the way they're doing things, and now our air here is really, really good. I mean, we get ozone alerts and things, and compared to China, it's nothing. So if you see this every day, and you've seen that every day for the 50, 60, 70 years you've been on this planet, are you going to think people can affect the atmosphere? People can affect you're going to have a much harder time than if you lived in this. Do you know that people are affecting the atmosphere? Definitely. So I think that has something to do with it. We're simple creatures. If we can see something, we believe it. If we can't see something, it's a little harder to believe. We're a product of our own success in cleaning up the air in some respect. I think if you transported that 30% of climate deniers to Beijing for a year, I think they might change their mind. Can humans affect the climate? Well, you know humans can affect the air, and if they can affect the air, they can probably affect the climate. So, yeah, if this is your world, you might think about it differently than if this was your world. So I don't come down as hard on people who don't believe the climate is changing, because they can't see it here in the US. I think it's a hard sell when you can't see something. That's Shanghai. That's a good day in Shanghai. When it's not like that, when it's clear, it's a gorgeous city. I've been to Shanghai before. It's amazing. But that's what it looks like normally. And it's because they have so many people. In order to have power for that many people, they have massive numbers of coal-fired electricity plants. And this is the smog from all that coal burning. It's extensive. It's substantial. China doesn't want it. Chinese know this is a problem. They spend $1 billion a year at least on healthcare costs because of air pollution. And that's $1 billion a year that they could use to have better infrastructure, give to the people. But now they're spending it on trying to get people not being sick from this. So they want to change it. It's just difficult. How do you get that much electricity through renewables? China's trying. They're the leader in solar panel production right now. But they just have a long way to go. Talked about CO2 levels. So there's a CO2 study center on Mauna Loa volcano in Hawaii. So out in the middle of the Pacific, far away from big cities, they have a little sensor on the top of this mountain that's been collecting CO2 data for the better part of a century now. And you can see what's going on, right? Average keeps going up. Notice how it bounces every year? See how part of the year it's high and then it goes low? That's 1 year's worth. What's interesting is it's high during the North American winter. What's going on with plants in North American winter? They're not as active, right? Out here, our plants aren't photosynthesizing. So they're not taking CO2 out of the atmosphere. During the summer, we get lots of plant growth, right? And they suck CO2 out of the atmosphere at a greater rate. One thing I didn't show you is that if you look at how the Earth is partitioned with land, most of the Earth's land's in the northern hemisphere. There's almost no land in the southern hemisphere. A little bit of Africa, a little bit of South America, but if you look, giant Asian continent, North America. Giant North American continent, north of the northern hemisphere. There's not that much land in the southern hemisphere. So there's not as many land plants. So when our land plants aren't working in the winter, they are in the southern hemisphere, but there's just not as many of them. So you get this up and down bounce. In the winter, more land plants. In the south, less in the north, less overall, higher CO2 rates.